Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Unusually Smooth Sections of Asteroid Itokawa. So, what do we see here? Well, here we see an image of an asteroid. Now, asteroids we don't normally get to see except as dots of light. There are hundreds of thousands of asteroids known in our solar system, but only a few of them have actually been studied up close, and this is one of those. The asteroid Itokawa was visited by the Hayabusa spacecraft back in 2005, and that's one of the images that we see here. Now we see some interesting structures on it, most notably a lack of craters. Now, lack of craters is usually associated with an active object, and something only 500 meters in diameter would not normally be expected to be that active. It also has a very interesting segregation of different materials. There are some areas that are very nice and smooth with no large boulders in them, and others that seem to have lots of boulders in them. And those are a couple of the things that we try to understand to learn more about asteroids. Remember, we've only studied a few of these. We've had a handful that have been flown by and studied, but we have not gotten good statistics yet to be able to really learn about asteroids overall. Now, one of the smoother areas was actually visited, and Hayabusa landed there, touched down, and actually collected some samples of material and brought those back to Earth. One of the earlier sample return missions that brought back material from an asteroid to be able to study it here on Earth. Why would we want to do that? Well, asteroids like this are some of the very early primitive material from our solar system, meaning that it's material that is really unchanged from the time that the solar system formed. So studying samples here give us an idea what the material was like that originally formed planets like Earth. Now, what happened on Earth? The material got heated up, it got melted, it got all separated and differentiated by different types. So on Earth, most of the metal is at the core, and the lighter materials, the water and the ice and the atmosphere, are up at the surface. Here we have everything mixed together, and we have primordial samples of the original material that formed our entire solar system. So sample return missions like this one here, as well as others, have really given us a peek into what the very early solar system was like. Now, Itokawa is also known as a near-Earth asteroid, an asteroid that does cross Earth's orbit. And there are simulations that show that maybe within the next few million years, this asteroid could impact Earth. However, that is not something that is easily predicted. Asteroid orbits are very easily changed. An asteroid that passes close to another asteroid can actually deviate its orbit by a tiny bit, which can make a very big difference over time. So accurately predicting asteroid orbits is much, much harder than predicting orbits of larger objects like planets. So you can imagine, if an asteroid went closer to a planet, its orbit would be changed a lot, whereas the planet's orbit would be essentially unaffected. So in calculating planetary orbits, you don't need to worry about the asteroids, but when calculating asteroid orbits, you not only need to worry about the planets, but other asteroids as well. So that was our picture of the day, titled Unusually Smooth Sections of Asteroid Itokawa. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.